G'day, this is the fourth video on circle theorems and angles in circles. Today I'm going to look at theorem 8. Imagine we have two chords running from A to B, that's one of them, and C to D is another one, and they cross somewhere in the circle. They don't necessarily cross in the middle, they just cross somewhere. The first, and we'll probably say that they cross at point P. The first thing that I need to acknowledge or understand is that this angle here must be the same as this angle here. If they're straight lines, it has to be that due to them being alternate. The other thing now I'm going to look at is, imagine if I just draw another chord from C to B, just sort of a pretend chord in there, and then I connect these two lines here and these two lines here. From, I think it's theorem 2, I can acknowledge that these two angles here must be the same angle as well. So what I've now got, and given that these two angles are the same and these two angles are the same, then these two angles also have to be the same as well. And now I've actually got two triangles which are similar. They could be exactly the same, I guess, they could be congruent, but at least they are similar because all of the angles are the same. So I'm going to draw those two triangles over here and make sure, like I'll draw them different sizes, even though I don't actually know what sizes they are. So this one is going to be APC, and this one is going to be called BPD. And so the angle A is X, Y, Z, and here the angle is Z, Y, X. Actually, I'll probably just rearrange. So just a little bit of selective editing because I think it's going to make it a little bit easier for me here. So that's D, that's B, that's X, and that's Z. Okay, just so that they look similar. Now that I know that they are similar, I'm just going to explore some of the lengths of these triangles and ultimately some of the lengths over here. So from here I can say that AP divided by PC is equal to DP divided by PB. Okay, just by using similar triangles. From here, I can actually say that AP multiplied by PB is equal to PC multiplied by DP. The reason that is significant is because if you have a look at this, that length there multiplied by this length there is the same as this length here multiplied by that length there. And that's pretty nifty. In fact, that's the proof that we're going to do for number 8. I just need to show you another situation that could happen, is that this up here was when they crossed in the centre of the circle. It's possible that they don't cross in the centre of the circle. It's possible that they cross outside of the circle, like in this situation here. So again, I've got two chords, A, B, and C, D, but they actually are going to cross somewhere outside the circle over here. You'll see that the same rule applies, but I might as well just go and prove it to you as well. So I'm going to connect up these two things here and these two things here, and again I'm going to form my similar triangles. If I also connect these two across here, I can tell you that that angle there is the same as this angle here. This angle here is the same as this angle here because they're straight lines. So again, I've got two triangles and they're both similar, and I can do the same thing again. Okay, I won't go through all of that, but essentially I get to those two similar triangles and then I can do the same formula. So theorem 8 says that if AB and CD are two chords of a circle that cut at a point P, which again may be inside or outside of the circle, then PA multiplied by PB is PC times PD. Quite a neat little trick that is there. Okay, so that's theorem 8, and in the next video I'll do theorem 9. Thanks.